Good day everyone, this is the presentation of Computer Security Project from group Please Let Us Graduate. The members for our group are Amelia, Chao Shen, Yaxing, Li Qi and Yi Wei. First, our group is using articles related to wireless sensor network in the project. So, what is wireless sensor network? Wireless sensor network is a non-centralized computer network that uses wireless data connections. It composed of two types of devices, which is sensor nodes and base stations. Sensor nodes can provide functions like sense, measure, and collect information from the surrounding, and base stations can store all information from sensor nodes and issue control orders to the sensor nodes. In the problem statement of the project includes security requirements and security threats. For security requirements, it consists non-repudiation and availability. Non-repudiation means the message previously sent cannot be denied by a node in non-repudiation property. This property can also be considered as repudiation of receipt, where the recipient denies the reception of a message. And for availability, it enables the service of sensor networks to different users at all times, even in the presence of malicious entities or unfavorable situations. Different hardware and software elements of the network need to be strong enough to provide services. Next, the security threats are impersonation attacks and denial of service attacks. Impersonation attacks are the creation multiple fake identities or duplication of similar identity nodes by one malicious sensor node. And denial of service attacks prevent any part of the WSN from functioning properly or punctually. They also cause jamming in the communication channel or power exhaustion from the nodes. For question 2 solution, as you see, this is a cryptographic timing diagram for the upgraded proposed solution. Before the sensor nodes send the data to the base station, it will first send the secure connection request to the base station. Then, the base station will generate a private key and compute a few calculations to create a digital signature. After the generation of digital signature, the base station will send the digital signature and message to the sensor nodes. In order to verify the digital signature, there are still some calculations to compute. Lastly, if the value of V is equal to the value of R, then the digital signature will be accepted. Furthermore, Figure 3 is about the encryption and decryption illustration. In the diagram, we can see the flow of encryption and decryption process of a message between Alice and Bob. Private and public keys are used to encrypt and decrypt in the asymmetric encryption and decryption. ECC does not directly provide the encryption method. Instead, it uses the hybrid encryption method through using the ECDSA, which is a key exchange method. Alice and Bob will select a random number and multiply it with the generator point in the elliptic curve, and the result will act as a public key. Alice will be using her private key to sign the message, and then Bob will use Alice's public key to verify that the message came from Alice. The private key of Alice never gets exposed to another person, so she is the only one who can access to the private key. Then the third question, in order to counter two security threats and achieve both security requirements in question 1, the extensive analysis is carried out using mathematical notations to achieve the security requirements of non-repudiation and availability, which corresponding to the security threats of impersonation and denial of service attack respectively. Backward recurrence algorithm is used in mitigating the impersonation attacks. An attacker who accesses the public key queue will face problems solving elliptic curve discrete algorithm, as the attacker won't be able to obtain much essential algebra unknown value and unable to impersonate the sender. This method successfully fulfills the non-repudiation as a security requirement. Next, figure 4 shows the propagation of nodes in broadcast network. Broadcast in WSN is a vital communication primitive due to the limited signal range. This leads to the existence of an issue of resource constraints on sensor nodes or limited battery power for broadcast authentication, and limited battery power can lead to denial of service attacks. To mitigate this threat, dynamic cipher puzzle DCP can be also implemented. Figure 5 shows the operations scheme of the DCP. With the use of DCP, complexity of the attackers to implement signature-based DOS attacks can be increased. Besides, DCP can also assure DOS resilience, and it's hard for the attackers to find the solution without knowing the session key and the index number that match the puzzle strength. So that's all for our group presentation. Thank you.